Okay, Assalamualaikum and hello everyone. So today we will go into a new chapter, chapter 4, which is chemical bonding. This chapter, okay, its subtopics is very related to each other. Okay, so you must master Lewis structure, molecular shape, and polarity in order to draw your orbital overlap and hybridization. And then you will learn this intermolecular forces and metallic bonding for the last two. Alright, so the first subtopic, which is Lewis structure, is something new, I think, for you to learn. So let's look at our learning objectives. You will learn how to write the Lewis symbol for an atom. Okay, note that the Lewis symbol is for an atom. Okay, and state the octet rule and describe how atoms obtain octet configuration. Describe the formation of the following bonds. We have 1, 2, 3 bonds: ionic bond, covalent bond, and dative bond using Lewis symbol. Okay, alright. So chemical bonding. Okay, you know we have molecules and compounds. So how does our hydrogen molecule, oxygen molecule, hydrogen chloride compound, okay, how do they stick to each other? How are they formed? Okay, they are actually formed. They actually have a force between them called chemical bond. That is the force that holds the two atoms together, okay, in a molecular compound. So when atoms, they react with each other, let's say A plus B, okay, they will form a chemical bond, depending lah what kind of chemical bond, okay. So when reacting together, only the valence electrons are involved. So electrons in the outermost shell, maksudnya yang dekat luar sekali, contoh they are the ones that will react with the other compound punya valence electron. Okay, so in order to show, okay, how these reactions happen, we will be using Lewis structures. Okay, so from Lewis structures, we can show the number of valence electrons and how these electrons are involved in the process of bond formation. Okay, so the bonds that we have tadi tu ada 3 lah. Okay, but before that I will show you what does Lewis symbol look like. Okay, so a Lewis symbol, it consists of the symbol of an element and dots or cross to represent the valence electrons. So in Lewis symbol, we will only show the valence electrons. So let's say for chlorine and bromine, they are both group 17, right? Okay, so I'll show you for chlorine first. It will have 7 valence electrons. So therefore, I will start with putting dots 1, 2, 3, 4, 5, 6, 7. Okay, so chlorine will have 7 valence electrons. So I am showing 7 electrons around it. Same as bromine, okay, since it is in the same group, okay, so it has, sorry, that's not how you sequence of putting electrons. So you should put 4 around it first and then baru you letak the rest. Okay, alright, so contoh, okay, if you have like same group elements, they will have the same number of electrons around it for their Lewis symbols. Okay, so for example kan, for group 14, like carbon, right? For carbon will have 4 valence electrons since it's in group 14. So the way you will draw your Lewis symbol is put carbon and then 1, 2, 3, 4. So since you have 4 electrons around carbon, that means that you will form 4 bonds maximum for carbon. So for example, chlorine, right? Tadi chlorine kita ada 1, 2, sorry, bukan macam tu ya anak-anak. 1, 2, 3, 4, 5, 6, 7. Okay, so from here we know that chlorine can form 1 bond. Okay, yang ni ada 4 bond. Alright, dia macam tu. Alright, so So this is basically the summary of how you will draw the Lewis symbol for different group elements. Alright, so make sure to draw it accordingly. If you notice here, okay, kalau ada dua electrons, valence electrons, you will put it separately, bukannya macam ni. Okay, ini salah. Right? Okay, so next we will learn the octet rule. So what is the octet rule? Octet rule tells you, it actually explains why our atoms, they react with each other. Okay, so your atoms from group 1 to 17, they all want to achieve the stable octet electron configuration like the noble gas. Like noble gas in group 18, okay, these atoms are stable. Okay, they have the stable electronic configuration. So all your other atoms from group 1 to 17, they all want to achieve this stability. Alright, so in order for them, group 1 to 17, to achieve stability, they will react with each other. Okay, so when they react with each other, we apply octet rule. So octet rule, it states that atoms tend to form bonds to obtain 8 electrons in the valence shell as an atom of noble gas. So basically what I just explained just now lah. So atoms will combine by gaining, losing, or sharing electrons to achieve stability as the noble gas configuration. So there are 3 types of stabilities that we have, okay, for your cations and anions. It is the noble gas configuration. Noble gas maksudnya group 18. Noble gas. Pseudo noble gas configuration. Dia seakan-akan noble gas. Half-filled orbital configuration. Maksudnya macam 3D5. Okay. 3D5 maksudnya half-filled lah stability tu. Okay. So let's look at noble gas configuration. So this is one of the stability that your group 1 to 17 elements can achieve. Okay, noble gas configuration. So for group 1, 2 and 13 elements, okay, they are electropositive elements. So they will donate valence electrons to form cations. Okay, electropositive maksudnya dia tend to lose electron, release electron, donate electron. So they will donate their valence electrons to form cations in order to achieve the noble gas configuration. For example, we have sodium in group 1. It will this is the electronic configuration, right? It will form sodium plus. Okay, that means they will remove 1 electron from the 3s orbital and achieve stable octet electron arrangement. Okay, here we can see that the electronic configuration is isoelectronic to neon. Okay, sama number of electrons with neon. So sodium plus ni dia kira stable lah. Okay, because dia punya electronic configuration sama dengan noble gas neon. Calcium pula, okay, this is the electronic configuration. So calcium is in group 2. So group 2 elements, they will donate 2 electrons. So that means that calcium will donate the 2 electrons in the 4s orbital and will be left with 1s2, 2s2, 2p6, 3s2 and 3p6. So Ca2+, calcium 2+, calcium ion has the same electronic configuration as argon. Okay, the isoelectronic to the noble gas argon. Alright. So group 1, 2 and 13 elements, they will donate, okay, lose electrons from the valence shell. As for group 15, 16 and 17 elements, they will accept electrons because these elements are electronegative. Maksudnya they have a tendency to attract electrons to themselves. Okay, so they will attract electrons to form anions. Okay, with noble gas configurations. So for example, we have group 16 oxygen. Okay, this is the electronic configuration. If you look here in your 2p orbital, you only have 4 electrons, and 2s, you have 2 electrons. So 2 plus 4 is just 6 electrons. So you want 8 electrons. So in order to do that, your oxygen will form O2 minus by gaining 2 more electrons in the 2p orbital. So now that in the valence shell, okay, the second shell, you have 2 plus 6 electrons, which is a total of 8 valence electrons, right? So O2 minus, dia punya electronic configuration is the same as the noble gas neon. Okay. Cl pun sama. If you look here, it only has 7 valence electrons. Okay. So to achieve stable octet electronic configuration, okay, they will have the type of stability noble gas configuration. They will gain 1 electron in the 3p orbital to form Cl minus. Ini apa benda saya buat ni? Ini salah ni. Okay. I think it was another noble gas. Okay. The next type of stability is the pseudo noble gas configuration. Pseudo means fake. Okay. Dia fake lah. Dia seakan-akan. Dia ciplak lah. Okay. So this pseudo noble gas configuration applies to D block elements which donate electrons from their 4s orbitals to form cations. Okay, so macam zinc in the D block element, it is a transition metal. This is the electronic configuration. So in order to achieve this pseudo noble gas configuration, it will lose 2 electrons from the 4s orbital of zinc. Okay. So to form zinc 2+, they will remove these electrons. Okay. First in, first out. So they are left with 3s2, 3p6, 3d10 in the third shell. So ini seakan-akan noble gas punya configuration lah. Tapi actually bukan. Tapi dia seakan-akan saja. Okay. Nampak macam. Alright. So dia punya third shell semua full dengan elektron. Okay. So dia seakan-akan noble gas tapi tak ada pun noble gas yang sama electronic configuration macam ni. Okay. Next type of stability is the half-filled orbital configuration. So you've learned about half-filled orbital stability. So half-filled orbitals are very stable, right? So this applies to D block elements that donate electrons to achieve the half-filled stability for their orbital. For example, manganese and iron. Okay, if you look at their electronic configuration, they have electrons in the 4s orbital. Okay, so in order to achieve the half-filled orbital configuration, that stability, they will lose electrons. Okay, so for manganese, it forms manganese 2+, removing these 4s electrons. Okay, and they are left with 5 electrons in the 3d orbital. So their 3d orbital is now half-filled. Okay, half-filled. Ada 5 je elektron. So this half-filled stability also applies to iron that forms iron 3+. They remove 2 electrons from 4s orbital and 1 from the 3d orbital. So they are left with 3d5. Okay, so this is stability of half-filled 3d orbital.